So, an exponential function is growth or decay. A graph of it is either an upward moving shape, like this, growth, with a whole number as b, a 2, a 3, a 4. A decay means that I have a downward movement that's going to have a fraction or a number less than 1. It could be a decimal less than 1 for my b value. So exactly what's on the board, I'm going to write here. And that's going to be f of x, or y, means the same thing. A raised to the power of x minus h plus k. The a is a left and a right, opposite sign, sign. The k is up or down. And I'm going to give you 4 samples, and we're going to describe the transformation. This time I'm going to use y equals 1/2 raised to the power of x plus 3. I'm going to write down 4 of them. 2 to the power of x plus 6. F of x to the power of 3 to the power of x, and then a big minus 1. F of x equals 2 raised to the power of x plus 2, and then a minus 3. Okay. I want to describe what's happening, talk about it. So, what does in the exponent position, what would an x, a plus 3 be? Look on the board. This is an h, you guys. This is my h.
Oh, left 3. Oh, wait.
Right 3. Ooh. What is it?
Left 3.
It's left because it's the opposite sign.
Oh, right.
You were right. No, left, guys, left.
Oh, I get it.
So dumb. All right. How about this 6? What's that mean? Oh, man, I should have made them different. That's not very creative, Casey Grant. Next time I should make it x minus 6. Okay. Then I gave you the k. The k is the big number at the end after the whole base and exponent. This is a minus 1. This is not opposite sign. This is as you see it. 1 down. And look at me. We're changing it. No. We're making this a plus 3. Because I need to be... So if it's a plus 3 at the end, what's that?
3 up, and then it would be 2 to the left.
Hold on. 2 to the left and up 3. It's a combo problem. Did you see that 2 up there?
Yeah.
So, an H, which is the horizontal, opposite sign. A K. All right. Let's talk about number 1. If you want to have different colored writing utensils, like a blue, if you have any colors, this would be beneficial. Okay. Vertical translations. Vertical translations are K. How does the value of K affect the graph of 2 to the power of x plus K? K moves up or down. Our parent function is 2 to the x. It's here on the board. 2 to the power of x. So, If you recall, 2 to the negative second, 1/4. 2 to the negative 1, 1/2. 2 to the 0, 1. 2 to the first is 2. 2 squared is 4. So that's my parent function. PF, parent function. Then, if I'm going to add 3, that means that I'm going to go first up 3. If I'm moving this up 3, my y-intercept is going to change. So look at my hand on the screen. If I'm moving up 3, I'm going to go 1, 2, 3. My y-intercept is going to go up 3. I literally could move every dot 1, 2, 3. 1, 2, 3. 1, 2, 3. You'll see I'm going to do the math where I'm adding 3 to my y value, but it's going to be the same as me physically just going 1, 2, 3, counting. You can count, or you can do a table of values today. So this means my parent function, which was 1/4, plus 3. What's 1/4 plus 3? 3 and 1/4. What's 1/2 plus 3?
1/2.
3 and a half. Don't forget about the 3. What's 1 plus 3? What's 2 plus 3? 4 plus 3. I'm going to plot those points first. I'm going to do 2 to the left, up 3 and 1/4. I'm now forgetting about my parent function in the middle because I added 3. 2 to the left, up 3 and 1/4. 1 to the left, up 3 and 1/2. -1, up 3 and 1/2. Just a little bit higher. It's still in the middle of a box. Let's zoom. 0, 4. This is my new y-intercept. One comma 5 over 1 of 5. 2 comma 7. So the curve is the same type of curve. I just shifted it higher because it had a plus 3. So again, you could literally just count 1, 2, 3, make a dot. 1, 2, 3, make a dot. Because our third J function is going to be my parent function. Take away 3. These numbers, 1/4, take away 3. 1/2, take away 3. 1, take away 3. 2, take away 3. 4, take away 3. So I'm going to write this in red. So 1/4 minus 3. How good are you at fractions? 1/4 take away 3.
-2 and 3/4.
Yes, that is right.
I'm literally correct.
Oh, no.
Saying it math.
1/2 minus 3.
Wait, no,
-2 and a half. 1. You please, let's focus. 1 minus 3. 2 minus 3.
And grandpa.
4 minus 3. 4 take away 3. I'm going to graph that in red. My XY. Sir. Get rid of it. Okay. -2 and then negative 2 3/4. So 2 to the left, down 2 3/4. Negative 1, comma, negative 2 1/2. 1 to the left, down 2 1/2. Yeah, because I'm shifting the black, the original, down 3. 0, negative 2. 1, comma, negative 1. Over 1, down 1. Over 2, up 1. The curvature is still the same. These have horizontal asymptotes that change because I move higher and lower. Like the blue has a horizontal asymptote of y equals 3. The red has a horizontal asymptote of y equals negative 3. Because I'm shifting my parent function. First I went up 3, then I went down 3. All right, we're going to do K again, but I don't have to graph it. Next page, please. Need I remind you that I'm still recording and I don't want any side talk? Please. Yeah, put it past my desk after. All right, if this is my formula, 5/12 is my y-intercept. My ratio is 4, which means quadruple. Raised to the x power. And then I say, you guys, I want you to shift this up 5.98, basically 6. Where would I put that 5.98 in my equation? Because this is what I've got so far. Does it go in the H position or does it go in the K position if I'm going up 5.98? K. That's going to be a plus, a big plus, and a normal size 5.98. Okay. Now I'm officially moving left and right. I'm going to start talking about H. H is my left and right. It's the opposite sign of what you see. So I'm only doing H now. We're forgetting about up and down. No more up and down for right now. We're just going to go side to side. That's this. The H has the power. H moves my graph. Left or right? So what would, let me give you a sample. 2 to the power of x minus 2 versus 2 to the power of x plus 4. What does this negative 2 mean for my graph? So I'm now not going to make a table of values. I just want you to count boxes. Every ordered pair that you see in my parent function, which by the way should have arrows at the end, I want you to count just 2 to the right. So every single point that you see, count 2 boxes over and make a new point. I'll do mine in red. Smooth curve, please. I'm still going to have a horizontal asymptote of y equals 0. I didn't shift up or down, so nothing changes. So, I'm not going to graph this one with the 4. Let's just describe it. Are you done graphing my red? So, what is this plus 4 going to do? 4 what?
Left.
4 left.
Or left.
So, I just did 2 samples. I'm going to basically ask you a repeat question. That's what this one says. But I need to read to you in mathematical language. Compare the graph of j of x, 2 to the x minus h. I don't know what h is. It could be left, it could be right. I don't know. With the graph of parent function, 2 to the x. When h is less than 0. You know what h means? Less than 0? Negative number. Whereas up here it was a positive number. So, if I have a negative number, here's 2 negative samples. 2 to the x minus 1, 2 to the x minus 3. They're both going to be opposite sign, 1 to the right, 3 to the right. Opposite sign. It's important for you to remember that. All right, last question, last example for notes. Example 4. How can you compare the properties of G with F and J? Woo, lots happening. I have the table of values for f of x. The graph of f of x is right here, this upper graph. This is f of x. That's this right here. This is the parent function. G of x. What did I do to get a 0.25 to a 2.25? Half to a 2.5. 1 to 3. 2 to 4. 4 to 6. What am I? Add 2. Is that the h or is that the k? Am I going up or down? Did I go up or down? I went up and down. It's the k. It's the k. So like for example, the f of x and g of x, one of them had a y-intercept of 1. F of x had a y-intercept at 0, 1, whereas g of x was at 0, 3. So we're moving up 2. G of x is this. Our parent function, up 2. But what happened with j of x? Here's j. If f of x is where my pencil is, parent function, what did I do to get j? Was that like what kind of movement to get to this j now low? J is not written on my table of values, so I have to just look.
Or down.
Down what?
Down 1.
Down 1.
Down 1.
That's going to be a minus 1 for my k. J of x, parent function, minus 1. And this is where we stop for day 1.
Yes. Day 2. It's on day.
All right, your homework, which I'm still going to keep on the video because I want people that, is these 2 pages right here. They both say 6.58 classwork on them. I want to give you my parent function table of values so that all of this page, can you turn to this page where it says 3 to the power of x?
Oh, damn.
All of this page is a 3 to the power of x. I am sometimes moving. Well, actually, look. These are all k movements. This whole page is either up or down. So here's the parent function for 3 to the x. -1 is 1/3. 0 is 1. 1 is 3. 2 is... I think that 0.5 lead is my least favorite because it breaks nonstop. So it's asking you to identify what happened with these. If you have different colors, that'd be so awesome. Because you have to graph all 4 down here. One of them is up 2. One of them is down 4. One of them is down 1. One of them is up 1. So if you have colored options, that's okay. I have some colored pencils. Markers are 4 choice. Marker's gonna bleed through to the other side, and you don't really want that.
Let's go.
So you're graphing all 4 of these. These are up-down movements. Can you guys please turn the page? I want to talk to you about the second part of this, like homework classwork. This is my exponent. What kind of movements are happening with this exponent? Left and right. Yes, because it says 6.5a on top.
Oh, so they're both homework?
Yes, they are. Classwork / homework.
Let's go.
Can you, let's write the parent functions for the 1/2. Well, drawing the parent function just means that you know what the original used to look like. So I'm going to put it in my homework answer key, the parent function, yeah. -1, 0, 1, and 2. I'm going to write out the work because you need to remember this. 1/2 to the -1 means the numerator goes to the -1. The denominator goes to the -1. I have negative exponents I have negative numbers in my exponent. What happens when I have negative exponents? They turn to a positive, but I have to, yep, reciprocal. Oh.
Let's go.
Okay. 1/2 to the 0. 1. 1/2 to the 1st. 1/2 squared.
To the 4th. 1/4.
1 squared over 2 squared.
4th. Let's go.
So that's the parent function. And then you would be, like where my pencil is, 1 to the right, 3 to the left, 2 to the left, 4 to the right. So you're going to have to shift. And I would love different colors. Even if it's black and blue and pencil and a colored pencil. Anything, so I can differentiate which is which. All right, you have 2 pages to do for homework, and you need to get it done before we leave. So I'm going to stop the video.